Welcome, everybody. I'm glad that you're here. Are you enjoying the conference? First time here? Yes? No? Maybe? Great. Okay, well, as you can see, the topic today is handling benchmarks for the second level cache in JPA using JMH. The topic is not going to be just JPA. Actually, what I want to showcase is a series of experiences on testing a particular thing, caching, but showcasing test cases and JMH. You can get the code for all the tests and the benchmarks at this particular location. So the two links are exactly the same. The other one is just a smaller one. Everything is open source, and they were peer-reviewed by some of the project members of the technologies that we're going to discuss today. I should point out that at any time, whenever you have a question, please let me know, and I will try my best to answer it immediately. We only have roughly 44 minutes, so just let me know when something happens. Okay, so the setting for this thing. I came up with this particular content. It is based on real-world experience. I'm working with a customer 3 years ago, and they had this thing. They had a big system running with Java EE technologies, Java EE 6, I believe, at the time. And they have a mix of several technologies just because, well, you can do this with Java EE. And they wanted to consolidate everything under just one vendor. And the selected vendor in that particular case was JBoss, Red Hat. The JPA provider they used to use in the past was EclipseLink. And EclipseLink gave them a lot of benefits. For example, the second level cache is enabled by default in EclipseLink, and setting it up is very easy. I think that you only have to annotate the classes that you want to see cached, and you can take all the defaults. And when we're measuring the performance for this second level cache out of EclipseLink for this particular setup, we were within the 2 and 4 seconds range, and we were querying thousands and thousands of elements. So the response that we were getting out of the system was pretty good. But then, of course, because they needed or they wanted to put everything under one roof, they said, well, let's pick the JPA provider that comes from Red Hat, and that is Hibernate. Let's put it in, and well, the results were not really very good. Without any caching, they were already having 40 to 80 seconds to every single request, and that was definitely not acceptable. And they didn't know exactly how to configure cache. It was not as easy as you would think when switching from EclipseLink to Hibernate, because the way that EclipseLink configures cache, it does it in a non-standard way, not using the JPA standard. So we needed a way to set up Hibernate to work in such a way that it gave us at least the same benefits as EclipseLink, or even better performance. The measurements that we had at the time were all done manually. So they were error-prone because we're humans. We will make mistakes. Everything was done taking measurements with print statements or logging. So matching the ins and out, the start and the end, it was a big mess. And the other thing is that, well, these numbers, these measurements were not reproducible across different environments. So we needed a way to be sure to have these repeatable conditions and to have accurate measurements. So the goal is, or was in this case, if we were able to configure Hibernate in a way that will behave very similar to EclipseLink, or perhaps even get better performance. Is there any caching option that we could use that will be compatible with the one vendor or one solution for what the customer was expecting? So we have a couple of candidates that we can combine with Hibernate. The obvious choice would have been InfiniSpan because it comes from the same vendor. But we also have Hazelcast, even though it's not exactly a caching solution. It goes beyond that. You can use it as caching for Hibernate. The other obvious choice would have been EHCache. It's been around for ages. And finally, we have Caffeine. if you don't know caffeine, caffeine comes from Google, and this is a next edition, the next version of what the Google Guava caching option used to be. So what we needed for this to work? We needed to make accurate measurements. We had to make sure that the measurements and the test conditions are equal and fair, so that if we take measurements from different environments at different points in time, we will be sure that the variation within each one of them will be close to zero, so that we have high confidence on the numbers. And we had to be sure that everything is repeatable. So our first approach was to use what with every single Java developer knows: just write a unit test. So what we needed to exercise is load the data into the second level cache and then hit it. So we'll make the measurements by hitting the second time. So this is very easily done by creating a pair of instances of Entity Manager. The first one will be used to load the data and warm up the cache, and the second Entity Manager will be used to record the measurements. So this is everything what we needed. Now the test conditions for this were, because we wanted to have quick and repeatable measurements, we switched to use H2. Now, first problem, we are no longer testing against a production grade database. So the way that the behavior of this particular database will push our numbers into a certain direction. The data set that we use at this particular point in time was a little bit small, 6,000 entities, and the actual production system had millions of entities that we needed to query. We were only querying a simple parent-child relationship because we only wanted to test out what would be the minimum unit of what would be the time between a very specific operation. We did not need the whole domain graph in order to make these measurements. And all the queries were read-only, whereas the system had write queries as well. And we limited ourselves to 50 iterations to warm up the JVM and have the bytecode be optimized if possible, and then take the measurements. Eclipse link will be our control, because this is what the previous system used to run. We will also configure Hibernate without any caching to also serve as a control to see if the caching option will be better or worse. And all the caching providers that we configured, the four that I showed earlier, will use the default settings in order to be fair to one another. Because if we can figure out which provider works better using the defaults, then we can tweak a very specific one to get better results. So we put everything in a unit test case using JUnit 4. Because we were using Java EE6, we could not use JUnit 5. 3 years ago, JUnit 5 was still getting just out of the door, so JUnit 4. So the code looks a little bit like that. There's a little bit more scaffolding in the code that you will see in the repository. But basically, we have our own very trivial for loop to do all the iterations, and the real deal happens inside that blue method called the execute benchmark. And the way that the execute benchmark, the first iteration, the code looks like this. As I said, we create an entity manager factory, and out of that factory we create two entity manager instances. The first one will warm up the cache, and the second will actually execute the measurements. So once we run this for a couple of times, we end up with these particular numbers. So we can see that Eclipse link is actually quite good. So the first column is reading from disk, because even though we were using H2, we were reading from disk. And the second column is how fast this particular provider is as reading information from the second level cache. I have to confess that I'm not a fan of many of the things that happen within the Eclipse projects, but I was honestly very surprised by how fast Eclipse Link is. It's really good. For some reason, it is the reference implementation for JPA 2.1. Then you can see Hibernate without any caching. It's 3 times slower than Eclipse Link. And then with the other providers, InfiniSpan is okay. And then Hazelcast and Caffeine, it starts to look like this might be the winners. And EHCache is still doing okay. Again, this was with a small data set, just 6,000 entities. So, all right, not so bad. We can see that warming up the cache is expensive in all of them. But once warm, almost all of them, except for plain Hibernate, behave quite like Eclipse Link. But then we have more problems. This was just one user, no concurrency, there was no contingency within different threads trying to grab access to the same resource, and the data set was quite small. So we needed to find a way to try to mimic the real world as much as we can, but trying to shading up all the weight that is not needed in order to get an accurate measurement. So here we have the next round. And we still did this with just regular unit test cases. We will have additional operations after the cache has been warmed. So after making the second measurement, or the first measurement for reading from the cache, we will clear the cache again, and then load it, and then clear it again, and then load it, and then query it again. So many other things, and it will do this in sequence. And we will add also concurrent modes. So at some point, we will hit the same database with 2, 4, 8, 10, 16 users at the same time, as much as many threads we have in the machine that we were testing. And we'll up the ante with the data set. Instead of just being 6,000 entities, we're going to grow to 60,000 entities, and we could go beyond that. The test code is actually quite ugly. So I'm not going to show it, but you can see it on the repository. And the concurrencies, the concurrent tests relied on using executor service and countdown latch and other tricks that you have to know, that you have to be aware with logging. So it starts to grow more beyond that. Just simply, I want to issue a query and get a number out of that. So we had to build our own custom testing benchmarking framework, and if it's custom, then there's bound to be something that is wrong. The infrastructure code, the how we do the measurements and how we do the reporting was also getting entangled with the actual testing. So we had trouble with not knowing if the measuring code was affecting the actual measurements. This is the problem that we have in quantum physics and quantum computer. If you measure it, you just affect it, you have no idea if it's the right thing or not. So we have some numbers here. The graph, the colors don't look very good, but I can show you here. So the first one, the first 4 operations, the first operation is loading the cache. Everybody is very expensive. The second number is hitting the second level cache. The third number is clearing the cache and read it again, and then a series of operations. Now, the peak on the top, the color is, let me see, is the black one. That is Hibernate without any caching. The numbers of after 21, that is concurrency. And we can see that Hibernate with concurrency and no caching is not very good. Somewhere there in the low level, there is Eclipse Link, and the Eclipse Link is behaving very good. And also, we can see Hazelcast and Caffeine, the blue and the green one, very close to the purple one. So that's our control. That's pretty good. InfiniSpan, which is red, is a little bit higher, so that doesn't give us a lot of confidence on that one. This is just a small data set. Every time that we load the data, it fits completely in the cache. So there is no cache invalidation. So now that we load the big data set, we expect to see cache misses and cache invalidation. And now we get this picture. At the bottom, almost flatlining, you can see Eclipse Link. And that also is Hazelcast and Caffeine. The yellow line, that is EHCache. Big data set, cache invalidation, EHCache, not good. And the red one, the other peaks that we see there, that is infinity span. So it's close, but no cigar. You can see the other options are better. So those are our conclusions. So if you want to have something very close to eclipse link, you have two choices: combine Hazelcast or combine with caffeine. If you want to go with infinity span, your numbers will not very good, and definitely H-cash will shut everything. Just don't use it. So we thought, well, these numbers are okay. Now we have identified two possible candidates. Yet we had some troubles. Our testing code was again entangled with the measuring code. We had no idea if by any time we were doing the measurements, we will be hit by a GC pause. We had no idea if the bytecode we were executing was warm and jitted and was optimized. We just could be in the middle of a switch between C1 and C2, or compiled code or not optimized code, and we had no clue. So the numbers that we get will not be reproducible. So for this thing, in order to be sure that we have clear numbers, we had to use a real good benchmark framework. So the first rule of writing benchmarks, and this is coming from Alexei Shipilev, a contributor to OpenJDK, is you do not write your own benchmarks. The second rule of creating benchmarks in Java is you don't do it. But if you have to, then you use JMH. JMH stands for the Java Micro Benchmark Hardness. Even though it says micro, you can use it for macro benchmarks, which is exactly our case. We're setting up a JPA provider and doing some measurements. Usually what you want to use JMH, or you see the examples outside, is that you want to figure out how fast a particular loop is for just handling a variable or a method or a field. Now we're just exploring this with more things. So JMH can be used to test all kind of code. If you want, you can test a Spring Boot application with JMH if you want to. It's just going to take a little bit while to warm up. So we needed now to decide what kind of benchmarks we needed to test, because the previous graphs show you different operations, but also concurrency. The advantages of JMH are that concurrency testing is supported out of the box. It can fork the JVM. It can create a different number of iterations, and you can tweak the different parameters so that you get different observable behavior. Now, benchmarks can be parameterized. If I show you the testing code, we have all different kind of variations. But in the case of benchmark, we could put everything in just one single class and one single benchmark and do the variations. So I can show you the code for this. Hold on a second. I guess PowerPoint is still showing, so I need to do that. And then go back there and make it bigger. There we go. So I said it's open source. The testing code is quite ugly. Setting up the database, and then here's where executing the measurement. We saw this earlier, and we have a for loop for all the iterations, and then here's the code for writing the reports, and it'll just get jumbled around. But in the case of the benchmarks, we start with a lot of annotations with JMH, and this is what we're doing. We're going to say that the scope of this benchmark is just a regular benchmark. We're going to do a single shot benchmark. There are different ways that you can do this. We're just going to make one measurement. The time unit for the measurements will be in milliseconds, because there's no way that these caching options will be faster than that. We will have 30 iterations for warm-up. So we're going to run our benchmark 30 times just to make sure that the code is warm and jittered, and then we execute the measurements. We only want to have 10 iterations for measurements. And just for good measure, we're going to fork the JVM 5 times. So how many times are we going to run this code? So 5 forks, 30 loops, and then 10 iterations. That is 200 times per number if we parameterize this. If we were to try to run this with a unit test, it will be much difficult. Notice we have we grab the number of available cores. This will allow us to figure out how many times, how much we can spend in the multi-threaded way. We have an entity manager, factory, and this little piece here, this little piece of code, is another annotation, another hint to JMH to say how many parameters we want. We will have two different parameters, 1,000 entities or 10,000 entities. And again, these 200 iterations that we saw in the past now are going to be translated into 400. And we set up our entity manager. This is very similar to what you see in unit tests, that we have something that can be done before the actual measurement and after, so like before class and after class or before after. So we do this setup. We're setting up the entity manager to be used once, and we load the cache, which is warm up, and then here in the iteration, first we create the entity manager and we create the data, right? And in this setup iteration, for every iteration, we're going to warm up the cache. So we're going to warm up the cache how many times? 400 times. And this is the entity manager that we're going to use to actually issue the measurements. And here is the only thing that we do. We annotate any methods with benchmark. We'll see this guy in just a moment. And the actual execution of the query is just regular JPA. And in the end, what we are just making sure the numbers will be given by JMH. Now this particular type here, which looks quite funny, black hole. If you have a method like this, execute query, that does not return a value, it is computing something, right? But if the value is not used, do you know what's going to happen when the code is optimized? Well, it's going to be deleted. So you're not going to measure a thing at all. You will be measuring the context switch within one method and the other. But what you think you're measuring will be completely gone. So the alternative to do this are two. Either I return a value from this method, or I use this object called a black hole, which will consume the result and will avoid the running JVM to discard the value and do some optimizations that we don't want. So we pass around this black hole object, and the other thing that we do with this black hole object is consume the results that we got from the query for each one of them. And that's how we can guarantee that even if we don't return a value, then this code does not get fully optimized aggressively, and we are measuring nothing. And this is the base test case. And every other test case that we have over here for caffeine and Eclipse Link will look similar to this. For example, the hybrid version that use no caching. Here's the actual query we're going to run, just a regular JPA query, an SQL query, and what will be the names of the test cases in case for the report. And this is only needed for reporting. The actual things that we're going to test out are these ones. So if I were to show, let's say, the one for caffeine, and I open this up in, I think it's source main Java org, and there we go. This is the caffeine benchmark. The query looks pretty much the same. The only difference will be is how this thing is set up, and that is using, let's see, I think it's in the resources. The default configuration for caffeine to define regions in the cache for each one of the classes. If we don't do this, then caffeine will be way, way up in the numbers, just like EH cache. Okay, so the code looks like this, and once we have run the benchmarks, we got some numbers. And the numbers look like this. The first blue rectangle, those are the numbers for Eclipse Link. And so that we can see for the small data set, for 1,000 entities, we got about 8.3 operations per millisecond. And we had an error of 0.4. So this is our base. The next number down is 10,000, so we're hitting cache misses and cache validation, and this sums up to 118 operations per millisecond. Okay, not bad. You can see the next number is Hibernate without any caching, and it's definitely way up. So the second blue rectangle that we see there is Hazelcast, and we see that the numbers are very, very close to Eclipse Link, and this is the one that is fastest. If I were to put this in a graph, the first data point is Eclipse Link, so that is the lowest. The topmost is Hibernate without any caching, and then we have the other caching solutions. Pretty close. Now let's blow this up with a big data set. The lowest point again is Eclipse Link. Hibernate without any caching. InfiniSpan is way up. Then Hazelcast brings it down. EHCache again is out of proportion, completely wasting time and space here. And then Caffeine brings it down again. So the conclusions that we can gather from running this over and over and over again, we got lots of numbers that look very much like this. Eclipse Link was always the fastest one. Hazelcast and Caffeine will give us the closest numbers. So if we needed to pick a different solution for Hibernate other than Eclipse Link, we will probably go with Hazelcast, given that, well, there is an open source version for that one, and there is commercial backing for that. For Caffeine, well, it's just open source. InfiniSpan was left as the third one solution, and even if we wanted to run it because of the one single provider, the numbers were not really very good. And EHCache with a big data set now, you can see, yeah, no, don't even try it. So the winner says, and the data says, well, we should go with Hazelcast. Even with big data sets, it behaves well. But remember that the database server that we were using was not the same was in production. The production queries required mutation because we needed to write, and we were only testing reads. And the customer, again, wanted to have everything under just one roof. Now, what we did next will shock you. So what did we do? We actually tested Hazelcast Hibernate in production and Hibernate InfiniSpan in production. And the winner was InfiniSpan. It was even faster than Eclipse Link by that much, 20%. So all our test cases indicated, and our benchmarks indicated that we should go with one solution, and then we tested InfiniSpan. It's like, what? How can that be? Well, it turns out that because everything is under the same roof, one provider, but InfiniSpan and Hibernate have been configured by default. Again, we were just testing defaults. The default configuration that's given out of the box from JBoss, EAP, and InfiniSpan and Hibernate is good enough. So you just have to enable the second level cache, and you're up into business. If you want, you can tweak a few little things, but you have to know what you're doing. But in order to get these numbers, we have to remember about pragmatic performance. So this is, I think Guild is around in the conference. He gave a really nice presentation at QCon San Paulo a couple of years ago, and there's the link to the proceedings and the PDF. And what we mean about pragmatic is that what did we do in order to obtain these numbers? We stripped the code to its bare minimum. We were using non-production queries. We were using non-production data. We were using non-production database. So we basically cheated by removing everything that we thought was weight, just to figure out how fast can I do this query, and you will get a number. But that number is the upper limit. If you really want to have a better number, you will have to test this with production hardware and production data, production databases. What we learned out of this experience is that you can start using test cases. You can start very quickly with JUnit, and you will get a rough idea, like a first estimate of where the solution may lie. But eventually, your code will grow out of proportion, and you'll have to have a real and good testing framework or hardness framework. JMH is this testing framework, and it gives you a lot of things for free. It has a very good documentation. There are lots and lots of examples. Actually, Shiplev, Alexei, has a very good set of documentation telling you the things that you should know beforehand and what will be the most common mistakes of people that get started with JMH so that you can avoid those mistakes and have better measurements much more quickly. Remember that the numbers that we obtain, even with both test cases and benchmarks, serve as a guideline because we're throwing away everything that we think we don't need. If you can, run JMH on production. You won't be disappointed. I have some parting thoughts for you. We have to be very, very aware that we will enter in this game of trying to figure out if a particular provider or a solution is good enough with some preconceptions on some biases. We have to be aware of this. We have to recognize them as soon as possible and eliminate them, which means you do not write these tests and you do not write these benchmarks alone. Always do it with somebody else. Ask for peer review in order to figure out if what the measurements that you're taking are for the actual thing that you need to measure, or it is something else that might be in the way and might be an obstacle. Be mindful of the shape of the input. As you saw, if the data is small enough, it will fit in the cache and the cache will behave very efficiently. But if the data is big and it doesn't fit in the cache, then the cache will behave in a different way and the numbers you will get will look different. The relationship within the domain objects will also affect you. We're having just a one level relationship, parent-child, but if we had more like 10 relationships, say that you want to graph a whole graph of objects with lots of relationships, the numbers we will have gotten will look a little bit different. Be also mindful of the system's environment. Are you running in the same production hardware? Are the configuration of the JVM settings are exactly the same as production? Is there any other environmental configuration that might affect the running process? Are you alone in the node, or do you have noisy neighbors now that everybody's running on containers? You should approach to these numbers, to the results, in a skeptical way. You will get a number, 15. Actually, let's make it fun. You get a number, 42. What does that mean? You have to take the number in context. And most importantly, iterate, iterate, iterate. It's not enough to run the test case and say, oh, I got a number. This is my guideline. Let's go with that one. No, you must run this over and over and over again to make sure to eliminate those particular problems where the code might not be JITed or there may be a GC pause that could cause one of these numbers to go very, very high up. I have two quotes that I would like to close with. One is, if we have data, let's look at the data, let's get those numbers. If the only thing that we have are opinions, then we go with mine. So if you're working in a team like this, everybody will have his own opinion, and whose opinion is going to win? The one that shouts harder, or the one that has the authority. And we don't want that. We want things to be not subjective, but objective. And the other thing is measure. Don't guess. I have a preconception that Eclipse Link was bad. I did the measurements, and it turns out to be really good. I thought that InfiniSpan would be good, given that it was coming from JBoss, and my number said it wasn't really good. But when I ran in production, I got surprised, and I got a really good output out of that. Everything that you saw today, all the libraries, JMH, and the code for the test cases and the benchmarks are open source. You can configure them, you can study them, you can use them as much as you want, as long as you follow the licensing terms. You also can contribute to open source very easily. If you encounter any problems with this source code, or these libraries, or any other open source library that you use in your daily work, file a ticket. Just let the people at the other side know that you encounter a problem, give it a set of steps to reproduce, and give it perhaps a little more information about the environment. Start that conversation, and that, my friends, is enough. If you have the time, if you have the passion, then provide a test case or even provide a patch. But contributing to open source is not always just giving back code. It's just letting people at the other side, I'm using your project, I found a problem, or I have the need of a feature, could you do this? Engage in the conversation. So these topics I covered in a newsletter. The first link is in English, the second link is in Spanish for any Spanish speakers in the audience. And I like to discuss topics like this and more stuff related to building and architecture, and other of my passions is JavaFX and desktop Java. So you will see some stuff like that. So I am Andres Almiray. I'm a Java champion from Mexico living in Switzerland. I enjoy working with open source, and I enjoy being here sharing my experiences and knowledge with all of you. I really love talking and doing open source, so I have joined all these entities. I'm a member of JCP Executive Committee, which if you want to know how we can make Java move forward, if you want to know or much more how we can make things better, then I will definitely would like to talk to you. So with this, I think we have a few more minutes for questions. First, thank you for your time. Thank you for being here. I know you have a choice. Thank you for choosing this one. If you want to know more about JMH or JUnit testing, well, please let me know. Thank you. You guys have any questions? Yes, Katie. So the question is, what was made different when doing the measurements in non-production code versus production code? Actually, the difference was that InfiniSpan is optimized to work with Hibernate out of the box. There's nothing that I needed to configure extra. Just the only thing that I needed to do for running the code in production and testing was say, I want to use the second level cache in the persistent XML file with just one property, and annotate the classes with the caching annotation from JPA. And that's everything that I need to do, nothing else. For every other provider, if I wanted to reach the numbers as close as Eclipse-Link or InfiniSpan, I would have to tweak and go with non-default configuration. Right? Yes. So the question is, what would be the footprint of adding this annotation? In a sense, what would be if I understand the question correctly, what is the weight or what is the impact of putting JMH plus the numbers? I can say that the added computational time for JMH is negligible. It still exists, though, of course. And if you really want to squeeze out the performance, you have to go down to business and know more about how the bytecode is optimized by the JVM and the compilers. So again, the documentation that Alexi has put out will get you very far to get most of it. But if you really need to squeeze out nanoseconds out of some particular thing, then you have to know bytecode at a very good level. All right. Well, if there are no more questions, well, again, thank you. Oh, another question over there. Yes? So the question is, if I try to investigate why EH cache behaves so bad. Actually, no, we didn't. when we start to look on the possibilities why this was the case, most of the entries that came out by Google said EH cache is good as long as you don't grow out of the size of the cache. And we had a little bit of a deadline to try to come up with that particular solution. And given the numbers that we were getting were very good for the other providers, we decided to leave EH cache on one side. I mean, there could be a way for non-default configuration for EH cache to be really low, but we didn't spend much time on that one. Well, thank you very much, and keep enjoying the conference.